Okay, today's topic is differentiation, or first we'll go through differentiability. So from the name, it will be clear. We have to decide whether a function is differentiable or not. So before moving forward, we have already discussed last year that what is differentiation, right? And we have seen how to find differentiation using limits. So we had seen this, that is f dash x, that is differentiation of function of x, is equals to a limit of that function at x plus h minus function's value at x divided by x plus h minus x, that is actually h. And when this limit of this, when h tends to 0, when h is very small. So this is the basic definition of differentiation, or this is how we find the derivative or differentiation. Now, when we say a function, or when we want to know whether a function is differentiable or not, we are going to use the same formula to decide whether a function is differentiable or not. So we know that differentiability is this limit, and if this limit exists, we say that the function is differentiable. And if there is a point where this function's this particular limit is not existing or doesn't exist, then we say that at that particular point the function is not differentiable, or that is the point of non-differentiability of the function, right? So this is the main formula which we have to understand. So this is the basic of differentiability. Now coming to the few other topics or the properties which we have already seen earlier, the rules. So we'll see those rules as well. The first rule, and the differentiation, right? This f of x can be written, the function can be written as f of x, or it can be written as y, or it can be written as u. Both are, all of these are actually function of x. Right. So here's, and the differentiation we represent as f dash x, or y dash, or dy by dx, or u dash, like that. There will be, these all represents the differentiation of the function. So now the rules are about the algebraic operations of functions and their differentiation. So if the two functions are being added or subtracted, and we have to find their differentiation, then you have to add or subtract their individual differentiation. So you differentiate them individually and then add or subtract them. So that is the first rule. This we have already seen it. Then the second is the product rule. That is, if two functions are product of each other, then what we are going to do? So differentiate the first function, write second function as it is, plus first function as it is, and differentiation of second function. Now this first and second function can be anything, any of the two here. So for example, if it is x sine x, and I have to differentiate this, then it will be differentiation of x into sine x plus the first function as it is, that is x, into differentiation of sine x. So because there is a plus sign here, so whether you reverse the order or you follow the same order, it doesn't matter. So this is actually sine x differentiation of sine x is 1 plus x into differentiation of sine x is cos x. So that is sine x plus x cos x. This is example of product rule. The order doesn't matter there, but if we have u by v, that is division of two functions, then it is the same thing which is above, but there is a minus sign here, divided by v square, the denominator square of the function which is there, which is the part of denominator. Only thing here is that v should not be equal to 0. That is what we have to make sure. Now in this part, the third, if you see third and second, so third and second, the numerator part is exactly same. Only difference is there is a plus sign in product rule and there is a negative sign in quotient rule or the third formula. But in the third rule, you see that there is a negative sign, or that means we are subtracting two things. So that's why now if you reverse the order, your result will be different. So in order to make it less confusing, we remember only one of them. I mean, you don't try to change the order. Always follow the same order so that you don't get confused, right? And here you have to follow the same order, and there will be a negative sign in between two products. That's all. So that's how we can avoid the confusion. Otherwise, you will be very, very confused. Now, the example of this, say for example, if we have to find d by dx of tan x, we have seen integration of sine x. Suppose we know integration of sine x and cos x, but we don't know integration of tan x. So this is nothing but d by dx of sine x by cos x. So what will be that? This will be something divided by cos square x. Then first differentiation of first function. So sine x differentiation into cos x. First means I'm talking about numerator. Then minus first function as it is, that is numerator as it is, and differentiation of denominator, that is cos x. So this is cos square x plus sine square x divided by cos square x. Now that is equals to 1 by cos square x, and that is equals to secant square x. Right. So these are the rules which we must remember, and these are very easy rules. At least the first one is, there's nothing to say there, but the second and third are important ones. So don't forget that. You'll be reading it or you'll be using it again and again. And not only in mathematics, you'll be using it in physics and chemistry as well. Right. Now, after that, in our 11th standard, we have also seen some important formulae. Right? That is some important derivatives of some standard functions. So, for example, we have seen few functions like x to the power n. So its differentiation is n into x to the power n minus 1. Next, we have seen trigonometric functions like sine x, and its differentiation was cos x. Cos x, its differentiation is minus sine x. And tan x, just now we have seen its differentiation is secant square x. So these were some important or standard differentiations or derivatives which we have already seen last year. So we have already seen how to check whether a function is differentiable or not, and then we have also seen some important rules. Now we'll see some different techniques of differentiation, which will be new for us because this is not something which we have already done, but We have studied this when I was, I think, discussing the tools of mathematical tools in physics, right? So that time we have seen some or few of these uh, methods. So to start with, we have derivatives of composite functions. So composite functions means function of function. This we have seen this year. That is, suppose there is a function of f of g of x. This is composite function. Example for this, say for example, sine of log of x square. So this is a composite function, and you can see that there are three levels of them. Sine is the outermost function, innermost function is an exponential function, and the function in between is actually log. So we read it as sine of log of square of x. So square of x can be just written as x square. So there are three levels here. Now these three levels, the method to solve or find differentiation of composite function is called chain rule. So we will go through the textbook definition and all later. For the timing, we'll understand what is this chain rule. So how to solve this. So for example, if the function is 2x plus 1 whole cube. If function is just x cube, then we know that y dash will be 3x to the power 3 minus 1, that is 2. This formula is directly, we have a standard function for this, that is x to the power n. Then here we have n into x to the power n minus 1. Now this is a standard formula, and all the standard functions which we have seen, they are direct functions of x. So for example, x cube is a function of x. It is cube of x. But if you see here, this is not cube of x. This is cube of 2x plus 1, which itself is a function of x. Now, in order to solve such differentiations, or in order to differentiate such composite functions, we do this. First, you take the outermost function. Outermost function here is cube. And you apply the standard result of cube here, right? So this one is the standard result of cube. So you apply this here. So cube of x, if the function is cube of x, our answer was 3 into square of x. So here it is cube of 2x plus 1. So f dash x will be 3 into square of 2x plus 1. But 2x plus 1 is still a function of x. It is not just x. So next we have to differentiate 2x plus 1. So now in the next step, we'll differentiate this. So this becomes 3 into 2x plus 1 whole square into differentiation of 2x plus 1 will be what? 2 plus 0. Differentiation of 2x is 2 and differentiation of 1 is 0. So this is 3 into 2, that is 6 into 2x plus 1 whole square. Now that's what is our final answer. That is 6 into 2x plus 1 whole square. This is what chain rule is, right? Chain rule is actually here, this part. Now here the depth of the function of, or depth of this function was 2, that is only 2 level, function of a function. It was not function of a function of function. So we have taken it only to level 2, that is we differentiated the first and then we differentiated the second, that is the inner function. So this, we differentiated first outer function, then the inner function. But this can go, this level can there is no limit to this level. For example, it can even go beyond this level too. So we'll see that as well. Say for example, it can be y is equals to sine of root of x square plus 3. Suppose a function is like this. Now, as I said, sine of root of x square. So it is a three-level function. Innermost function is x square plus 3. Outermost function is sine. So first we have to differentiate the sine function, right? Then the square root function, and then the polynomial which is there inside, that is x square plus 3. Now, before going forward, just see here. I don't know whether you still remember the differentiation of roots. Say for example, if it is root x, so what will be its differentiation? So we have to understand that root x is nothing but x to the power 1 by 2. So now x to the power n formula will be applicable to this. So y dash will be n, that is 1 by 2, into x to the power n minus 1, that is 1 by 2 minus 1. So this becomes 1 by 2 into x to the power minus half. So that is actually 1 by 2 root x. So if it is root of x, if the function is root of x, its differentiation is 1 by 2 into root of x. So that we have to keep into mind, because that we'll need in the second step of this function while we are solving this function. So now what will be y dash here? Here, sine's differentiation. The first step, you have to differentiate the outermost function. Outermost function is sine function. So its differentiation will be cos of whatever is there inside, as it is you have to write. And then what do we have to do? We have to differentiate the second level of the function, that is root of x square plus 3. Now in the second step, we do the same thing. First thing, you write as it is, the first function or the outermost function's differentiation, that will be written as it is. Next, we have dy by dx of this root function, and this is the differentiation of root function. So that is 1 by 2 root x square plus 3. Now what do we have to do next? Now we have to differentiate this x square plus 3 as well, because that is also a function. This x square plus 3 is not yet resolved, not yet differentiated. So this is cos root of x square plus 3 into 1 by 2 root of x square plus 3 into differentiation of this will be 2x plus 0. So this is equals to this 2, and 2 gets cancelled. So this answer will be equals to x divided by root of x square plus 3 into cos of root of x square plus. So this is the answer. And that's how we are going to solve such problems which are having a function which is function of another function. Or in one word, we can say that this is how we are going to solve composite functions. We are going to differentiate composite function, and this rule will be called chain rule. Let's solve some more problems based on this. Fx is equals to sine of x square. So here level is only 2. Sine of, that is outermost function, and x square, that is innermost function. So we have done more complex problem than this, but still this will be what f dash x is. Sine's differentiation is cos. So cos of whatever is there inside. And then differentiation of x square. So that is cos of x square into 2x. That is the answer. And with time or more practice, you will be able to, do it without writing this d by dx. So you will be able to write it just like this, that okay, outermost function is sine, so its differentiation will be cos, then x square, then differentiation of that, that is 2x. So you'll be able to solve such problems in one step, right? Now, suppose function is something else, and some similar function, say sine x whole square. This is difference, or it will be written as sine square of x. Now this is square of sine x. So outermost function is square. I hope you understood this, right? So now if we have to solve this, if we have to find f dash x here, so outermost is square. That means x to the power 2, or x to the power n formula we have to apply. So that is 2 whole square sine x. So 2 sine x to the power 2 minus 1, that is 1. And then differentiation of sine x. So this will be 2 cos x, sorry, and this is 1, right? So 2 sine x to the power 1, and sine x differentiation is cos x. So this is actually sine 2x. You can see there is very small difference here in the function, but the answer is totally different. One more problem. Suppose the function is tan of 2x plus 3. So outermost is tan and the inner function is 2x plus 3. So tan's differentiation f dash x, tan's differentiation is secant square x. So this is secant square but not x, whatever is the function inside, that is 2x plus 3. And then differentiation of 2x plus 3, that will be 2. So I can write it in 2 steps itself. So that is 2 secant square 2x plus 3. Next, say the function is sine of cos of x square, sine of cos of x square. So this is where the level is 3. So f dash x will be the outermost function sine. Its differentiation will be cos. So cos of whatever is there inside. And then whatever was there inside, differentiation of that. Now what is there inside? Cos. So differentiation of that will be minus sign. So we'll write minus sine of x square. Now next, it is not minus sine of x still. So there is a function here which is still left to be differentiated, and that is actually x square. So its differentiation will be 2x. So now what is our answer? Our answer is 2x, and there is a negative sign, so to take that as well, minus 2x into sine of x square into cos of x square. So that is the differentiation, that is minus 2x sine x square into cos of x square. Right? Now if you don't understand this particular thing, the second step, if it is confusing for you to write in one single step, you can solve it in multiple steps as well. So that's not wrong. You can write it as cos of x square into d by dx of cos of x square, that is the innermost function. and in the internal function, that is differentiation of cos of x square. So this will be cos of x square into internal function is cos, so its differentiation will be minus sine of obviously x square, and then the function is x square, so its differentiation, that is d by dx of x square. And then the third step, that is cos of x square into minus sine of x square into 2x, and then you can rewrite it in the simplest form. So both the answers will be same. It is up to you, whatever is more easy for you, you can opt that. If you are able to solve it in the single step, well and good. If not, you can do it in multiple steps. That is, step by step, you can write as well. It doesn't matter. So that is differentiation of composite functions or function of a function by applying chain rule. The next method, sometimes we will have functions where these x and y will not be easily or will not be directly separated, right? For example, till now we had function directly given in this form, y is equals to f of x. We may not have this always. For example, suppose what if function is x minus y is equals to pi. Now again, solving this is easy. I can still write it in that form, that is y is equals to x minus pi. So now I have this function in this form, that is y is equals to f of x. And now if I have to find dy by dx, that is just dy by dx of x minus pi, that is 1. So I can still solve it, and it was simple, so I did it. But there is another way of doing it, that is you start differentiating this on both the sides, that is d by dx of x minus y is equals to d by dx of pi. Pi is a constant, so that differentiation is 0. This differentiation d by dx of x is actually 1. D by dx of x will be what? Will be 1. So 1 minus d by dx of y, that is dy by dx. Now what do we have to find? Dy by dx. So we have an equation in form of dy by dx. So from there I can say that dy by dx is equals to 1. So in both the steps we have got the same, or in both the methods we have got the same result. Now here you will say that okay, the first method was easy, which is easy, no doubt. But the application of second method comes or becomes useful when you are not able to express the function in that form, that is y is equals to a function of x. When we are not able to express that, in that or in such cases, we will be using this method. Like for example, if you have y plus sine y is equals to cos x, there is no way I can write it in that form, y is equals to some function of pure function of x. I cannot write it. Now this type of functions, or this, when it is written in this form, it is called implicit function. That is the functions which we see here, right? Those functions cannot be separated. So they are together, they are always together. You cannot separate y on one side and x on other side. Now in order to differentiate such functions, the method which we have seen, that is start differentiating both sides, will be useful. That is, it is d by dx of y plus sine y is equals to d by dx of cos x. So in this side, in the right hand side, we have differentiation with respect to x of a function, which is completely a pure function of x. So that is only x involved on the right hand side. But here you have both y and x. So the first part will be what? Will be d by dx of y, and then d by dx of sine y, and y is a function of x, we know that. So on the right hand side we have minus sine x. Done. Now dy by dx as it is. Second part is sine of y, and y is a function of x. So it is actually a candidate for chain rule. Sine is a function of sine of y, and y is function of x. So apply the chain rule. That is, differentiation of sine y is cos y into differentiation of y, that is dy by dx. This is equals to minus sine x. Now obviously in this I can take now dy by dx common, and I'll have 1 plus cos y on this side, which is equals to minus sine x. So from this I get that this dy by dx is equals to minus sine x divided by 1 plus cos y. This method is called implicit, or solving implicit functions. So this is the second method. First method, the different method was a chain rule. Second is this method for implicit functions. There is a use of this implicit function. We have seen differentiation of sine, cos, tan, but we haven't seen differentiation of inverse trigonometric functions. So suppose we have to solve that now. Say for example, our function y is equals to sine inverse x. So here it is separated, y on LHS, x on RHS, but we don't know the formula for this, so we cannot differentiate it right now, right? So how to solve such problems? So, and if we are able to solve such problems, we'll come up with a standard formula for uh, all these inverse trigonometric functions. So now I will have to write it in a different way. How can I write it? I can write it as sine of y is equals to x. Now this is a function for which we know differentiation. We know differentiation of x. We know differentiation of sine y as well. So differentiation of sine y will be cos y. And y is a function of x, so that's why I apply chain rule, that is dy by dx, and that is equals to 1, because dy by dx of x is 1. So what is dy by dx here? Dy by dx is actually equals to 1 by cos y, and from this I can actually find what is cos y. So cos y is root of 1 minus sine square y, that is root of 1 minus x square. So dy by dx is equals to 1 by root of 1 minus x square. This is an important result. So now based on this method itself, we will be finding in differentiation of all the inverse trigonometric functions, that is sine inverse x, cos inverse x, tan inverse x. So you can try that yourself and you will come up with 6 results. One of them is here, sine inverse x. Its differentiation is 1 by root of 1 minus x square. So like this, you will have 5 more. So that is the assignment for you before the next class. That is, come up with differentiation of all these inverse trigonometric functions, right? That is cos inverse x, tan inverse x, secant inverse x, cosec inverse x, and cot inverse x, right? So that's all about